Hi, and welcome back. This PowerPoint is just a quick review of ozone, mainly the bad ozone, the ozone that forms in the troposphere, caused by humans, aggravates our asthma. I'm going to focus on that type of ozone. There is also the good ozone, so I want to make sure we're clear on what we're talking about. So I'll start with that and then get into kind of the chemistry of the bad ozone. I would recommend printing some of the notes that I sent you, I emailed you. Maybe have those in front of you while I go through this PowerPoint. It may help to have those notes in front of you. All right, so first, what is ozone? It's just a gas, it's just a molecule. So tri means three, so it's just three oxygen molecules bonded together. That is it, nothing fancy. It is a gas that can be found in the atmosphere. That's it. It is about location. That's what determines whether ozone is good or bad. Ozone is just ozone. It's always three atoms of oxygen bonded together. It doesn't matter where it's at, but where it's at affects whether we interact with it or not, and whether it can harm us or not. So we have to make sure you first know what's the difference between the troposphere and the stratosphere, and then you'll see. So the troposphere, that's the layer in which we live. That's the atmosphere that we're in right now, surrounding us. It's mainly nitrogen in the form of N2, two nitrogens bonded together, 78%, and oxygen, 21%, and it's two oxygens, O2, bonded together. So what you're sitting in right now is 78% nitrogen, 21% oxygen, N2 and O2, and then a little bit of carbon dioxide and maybe some other gases. That's the troposphere. That's what we live in. But above the troposphere is kind of the next layer, I guess you would call it, of the atmosphere. And we call that the stratosphere. In the stratosphere, you find something you've probably heard of before called the ozone layer, or the ozone shield. There's I don't want to call it a layer, or really it's just what's the word I'm looking for? A bunch of ozone gas molecules that have sort of congregated. That's not really the best word, but it gets at the point. That have sort of built up over time. Maybe that's better. Ozone gases that have built up over time in the stratosphere and now create this kind of layer that blocks us from UV light from the sun. And UV light is harmful. It can lead to skin cancer. It can kind of sunburn plants. It can damage living things. So this ozone in the stratosphere is that ozone layer maybe you've heard about before. So I put this picture on. It's the greatest, but hey, it works. So if this is Earth and we're right here, can I draw a stick figure? Oh yeah. Ooh, legs, maybe some arms. All right. So there's you or me, and we're on Earth and we live in the troposphere. So like I said, 78% nitrogen, 21% oxygen, a little bit of other things. But then above that, up here, we've got the stratosphere, and we don't really get into the stratosphere, right? We're not up in there, but that's where we find this ozone layer, this lots of ozone gas that's built up over time, and it does block us from UV light from the sun. So it keeps that UV light from reaching the Earth. So that makes it a good thing. Ozone that's naturally occurring, that built up over billions of years actually, from plants photosynthesizing and releasing oxygen. It built up over many, many, many millions of years. This ozone built up in the stratosphere. It absorbs UV light, shields us from that UV light. It is a good thing. Happy face. Right? But there's some bad ozone. That ozone is created by humans. It's created by us. It's a part of the smog that we see here in our own city. That brown, hazy stuff in there, there's ozone in it. So that smog that we see contains ozone. That's tropospheric ozone, or ozone in the troposphere. That is bad. It's a human-caused air pollutant. That's the ozone I'm talking about in this PowerPoint. The human-produced, the bad stuff. So no matter whether it's in the stratosphere or in the troposphere, it's still O3. Ozone is always O3 no matter where it's at. It's just we don't go into the stratosphere, so it doesn't bother us up there, but actually it protects us from UV light, so that's a good thing, right? The ozone in the troposphere, we have produced it. Humans have made it. It aggravates our eyes, bothers our asthma. it makes smog, or is a part of smog, it's a problem. That's what I'm focusing on. So just the same idea, but I thought this was a nice picture to illustrate the point again. So we're focusing on tropospheric ozone, ozone in the troposphere, the bad. Sometimes it's called ground level ozone because it's like at ground level. It's human generated. It's an air pollutant. Right? So it's a problem. It was identified, or is identified, I guess I could say, and regulated by the Clean Air Act. Starting back in the 70s, the Clean Air Act identified 6 or so air pollutants, and they set what are called national ambient air quality standards. So for every one of those air pollutants, only so much can be emitted or in the air, and it's constantly modified, or not modified, monitored. Monitors is what I'm looking for. So the EPA monitors nationally, and then there's state monitor agencies like the California Air Resources Board works with the EPA and reports to the EPA for what's going on in California. And then locally, we have the San Joaquin Valley Air Pollution Control District, on Gettysburg. I think it's not too far from us, but kind of near the mall, maybe. The San Joaquin Valley Air Pollution Control District locally monitors these air pollutants in our air, and they have to send that to the California Air Resources Board. They send that to the EPA. It's constantly being monitored under the Clean Air Act. And for ozone, one of those pollutants, we are routinely out of compliance. We are routinely over the limit that is outlined in the Clean Air Act, and we do pay fines and get in a little trouble for that. So the San Joaquin Valley Air Pollution Control District is constantly putting in programs to help us reduce our ozone production. It is a problem for us and costs our city some money, gets us in a little trouble. So how does it form? As I said, this is formed by humans. This is a man-made problem. So how does it form in the troposphere? It's not here naturally. So it starts with something called nitrogen oxides, got here in red. Nitrogen oxides are made by humans. They react in the atmosphere to then form ozone. So this is kind of the starting point. Nitrogen oxides would be called a primary air pollutant. They are created directly by humans, and then they react to make ozone. Ozone would be a secondary pollutant. It reacts in the atmosphere to make that. So where do these nitrogen oxides come from? And this is that brown, hazy stuff you see in the sky here in Fresno. That's nitrogen oxides. It's a brown, kind of hazy gas. So I mentioned the air is 78% nitrogen and 21% oxygen. So right there, if you look, NO, nitrogen oxides. So nitrogen and oxygen are in the air, and they're their own thing. You got N2, you got O2. They're hanging out doing their thing. Well, let's say your car, really anything that would burn fuel, but cars are probably the most common thing in your life or what you're familiar with. So you fire up your car, you've got gasoline in your car, but your car also has to pull in air, right? You need oxygen to burn, right, for combustion. So your car also pulls in air. And in a chamber, the gasoline and the oxygen from the air actually mix. And there's a spark plug that ignites that, gets things moving. So in your car, you're burning gasoline, right? There's a spark that ignites that. You've got gasoline. You need oxygen to make that burn. So your car pulls in air. Well, when your car pulls in air, your car cannot separate oxygen and nitrogen. It just pulls in air. So when your car pulls in the air, so the gas can burn with the oxygen, pull in nitrogen too. Nitrogen gets pulled on along with it. Well, at very, very high temperatures, it gets hot in your car when you burn gasoline. So at very high temperatures, the nitrogen and the oxygen that are naturally found in the air combine. And sometimes they're called NOx, N-O-X. And the reason for this X is, oops, not a circle, my apologies, is that sometimes it's NO, sometimes there's two oxygens, sometimes it's even N2O. So the whole idea of this NOx is that it's nitrogen and oxygen combined in different forms. And then that goes out your tailpipe. So this would be called a primary air pollutant. It comes right out of your tailpipe from combustion in your car, from something humans are doing. It goes into the atmosphere, makes that brown, hazy, ugly. Okay. All right, well, now what happens next? So once that nitrogen oxide, let's say it's nitrogen dioxide, and see if I can do this. And oh yeah, dioxide too. Let's say that comes out of your tailpipe, goes up into the atmosphere, like I said, creates that brown hazy gas. Well, the sunlight hits it, and the sun generates UV light, and UV light is a molecule buster. It breaks apart molecules, busts apart bonds. So when the UV light hits the nitrogen dioxide, a single atom of oxygen breaks off because it's NO2. So one of those oxygen busts off. This atomic, this single oxygen, is just like, I need something. I got to bond with something, right? It wants to fill those other electron level. It's like, I got to bond with something. It's a radical. It's looking to bond with something. And what's out there to bond with? The atmospheric oxygen. So this single oxygen that busted off the nitrogen dioxide reacts with the O2 in the atmosphere. And when they hook up, 1 plus 2 equals 3. And that is ozone. So that's it. It's happening in the atmosphere. This would be considered a secondary air pollutant. It was caused by reactions in the atmosphere after that primary nitrogen dioxide was released by the cars. So I gave you or emailed you a handout with this all typed up. I think I've done it twice, 2 different ways. So check your email, print it up, take a look at it. I've just got some more pictures illustrating this same exact thing, just to kind of, some people like pictures. So here's this, right? So nitrogen dioxide, and it could be NO, but let's say this comes out, oh, can I do it? Car. Oh yeah, that comes out of your tailpipe. Your car pulls in air to burn the fuel. Nitrogen and oxygen are in the air. They get into your car, it gets really hot, and they combine to form nitrogen dioxide. That comes out your tailpipe. Once that gets into the air, it gets whacked with some UV light. I like this picture because it kind of shows it like the nitrogen dioxide gets whacked by UV light, and a single oxygen busts off. So the NO that was right here, right, busts apart from, so UV light's kind of a molecule buster, and that busts off there. Well, that single oxygen, it just does not like being alone. It wants some electrons. So what's it going to hook up with? The O2 that's already in the atmosphere. I said 1 plus 2 is 3. That's it. Again, same picture, right? You've got that in the atmosphere. It gets pulled into your car, right? At really high temperatures, it combines. Gets whacked with UV light. A single oxygen busts off. That single oxygen wants to hook up. It hooks up with O2. You get ozone. So same thing, just different pictures to illustrate the same point. All right, and that summarizes it. Again, so check your email. I've got this all typed up for you. All right. So a few side notes. The formation of tropospheric ozone, it's generally worse for us anyway in the summer, and in general it is. Hot, sunny days. You need UV light. The heat seems to really bake it and make these reactions speed up, just makes them a lot worse. So hot, sunny days. So usually warmer summer months, we have more of a problem with ozone. We're usually over our limits, you know, in June, July, we're in some serious trouble. So we're usually over those limits in the warm, sunny summer months. Usually ozone levels are highest from noon to 5 because that's when the sun's up. Not always, but generally that can be the case. Levels are often higher actually Monday through Friday because the commute, people are driving more. On the weekends we're driving a little less. So in places like Los Angeles, they'll find like in the morning, the nitrogen dioxide is being released by the cars. And then around noon when the sun is peak, it starts hitting that nitrogen dioxide, whacking off an oxygen, which starts reacting to make the ozone. So by 5 o'clock, the levels are pretty high. Just a little side info. There are something called VOCs, volatile organic compounds, very fancy. And these seem to, or do, I guess, exacerbate or make ozone formation worse and lead to the creation of some other nasty things in our atmosphere. I wanted to add that in as a side note. VOCs are really think of things that evaporate and have those fumes. So when you're pumping gas in your car and you can smell the gasoline evaporating, that evaporated gasoline is a VOC. If you've ever used acetone as fingernail polish remover, so if you've ever been removing nail polish fingernail from your fingers or your nails, and you can smell those fumes, or sometimes you use markers or spray paint, and you're like, whoo, what's that? Those fumes, those are volatile organic compounds. So things that evaporate and have those really kind of nasty fumes that even give you a little headache. Those are generally VOCs. Okay? Well, we've got tons of those, from gasoline pumps to leaf blowers to industrial processes that are releasing these vapors into the atmosphere, and they're called VOCs. Well, they further aggravate ozone formation. Basically, they just get in the mix. And from doing a little research trying to find a better like chemical reaction for you guys, and what I found is the reactions are varied, they're complicated, so usually they'll just sum them up like this. They'll say volatile organic compounds, evaporated gasoline, evaporated paint thinner, are involved in a series of reactions in the atmosphere. A series of reactions, oh, it should say atmosphere, not atmospheric. They react with the nitrogen dioxides that are coming out of your car. The sunlight, the UV light, the heat really kind of affects them. And they all react together to make ozone, nitrogen dioxide that can react to make more ozone, and these things called PANs, peroxyl, I can't say it, nitrates, and create like this soup of gases in the atmosphere. So it kind of sums it up down here. Like all these things together can make ozone. And I have this picture. It's generally called photochemical smog. It's like a soup of chemicals. So photo, because UV light is involved. Chemical, lots of chemical reactions. So you've got like the nitrogen dioxide coming out of cars and burning fuels, right? Nitrogen dioxides. Oops. Hydrocarbons would be like evaporated gasoline. More evaporated gasoline. So these would be like VOCs here. Oh man, that's pretty bad. If you see hydrocarbon, VOC is the same thing. Hydrocarbons are evaporated gasoline. VOCs is like a bigger category. Evaporated gasoline plus evaporated paint thinner. But all of those react with oxygen in the atmosphere. They react with ultraviolet rays to create photochemical, didn't mean to cross it out and circle it, photochemical smog. It's like soup of nasty irritants in the atmosphere. Well, what's the effect of these irritants, particularly tropospheric ozone? Those days when the air is like the red days, when they say don't go outside, don't play sports, and if you do, if you have asthma, you feel like you can't breathe, that's the ozone. I really notice it bothering my eyes. Those days when you go out and your eyes are burning, that's generally ozone. It can give you a scratchy throat. It can inflame your airways and cause like that shortness of breath. If you have asthma, you don't want to be out on those red days when the ozone is high. Right? So really the respiratory distress. So this is supposed to be your normal airways in your lungs, and if you look, it's like nice and open. But when you have asthma and you're exposed to ozone, you get tightened muscles, and you can kind of see this mucus starts to get produced. Your own immune system is producing mucus. It's supposed to kind of protect you, but that clogs your airways too. So you just get that real respiratory distress when ozone is there. There's evidence that the ozone even scars our lungs a bit, makes them less elastic. Ozone can affect plants. It can get into what are called the stomas, into the leaf, and it can damage the chloroplast where photosynthesis occurs. It can reduce photosynthesis. The chloroplasts have that chlorophyll that makes the leaves nice and green, like this. But when you add ozone, they get kind of brown and red because the chlorophyll, the chloroplast is damaged. They can't photosynthesize as efficiently, which could often mean death for a plant. And if you see here, this is the yield, like the growth, how much crops you're producing. And as ozone increases, it's parts per billion in the atmosphere. as the ozone increases, if you look, your crop yield generally goes down because it's damaging their ability to photosynthesize, and then that would damage the plants. I didn't really find any great pictures, but ozone does damage materials, particularly rubber. You may notice that your windshield wipers can really get like crumbly over the summer. That's usually the UV light along with ozone. So it can damage materials. And then lastly, the solution would be obviously using your cars less. If that nitrogen dioxide is produced from burning fuels, well, if we use less cars, we carpool, that would help. This one, they said refuel your car when it's cooler, because if it's cooler, less gasoline would evaporate and create those VOCs. They're trying, the San Joaquin Valley Air Pollution Control District is trying to eliminate leaf blowers, gas-powered lawnmowers, because they also release that evaporated gasoline, those VOCs. So there's some things you can do to reduce that. So be sure, check your email, print up the notes that I sent. I think they'd be pretty helpful. Let me know if you have any questions.